Welcome to another episode of Math Made Simple. I'm Miss Munah and I'm a math specialist here at the Pi Lab. In this video, I'll be analysing some common examination questions. I've put the question in a handout and you may download a copy for free by clicking on the description box below. So let's get started. Today we're going to be talking about how we can convert recurring decimals into fractions. Now, what do you guys remember about recurring decimals? If you have learned this earlier in school, you will recall that recurring decimals are pretty special decimals. Why? Because their digits repeat. For example, we can have a recurring decimal that looks like this, 0.5 with a dot above the 5. Now, what does this mean? The dot above the 5 simply means that the 5 repeats. So if you're going to write this down in expanded form, it will look like this, 0.555 with 3 dots behind. Now, what do the 3 dots mean? It simply means that the digit 5 over here keeps repeating and it repeats until infinity. So instead of writing down all the digits, which is impossible by the way, we are just going to write down the 3 dots at the back. Now, another type of recurring decimal can also look like this, 0.18 with a dot above the 1 and above the 8. Now, what does this mean? It simply means that the digit 1 will repeat, which is then followed by the digit 8 that also repeats, and they will take turn to repeat. So if 1 gets his turn, the next turn will be 8, followed by 1 and another 8. So to write down this decimal in expanded form, you will get 0.18, 1818, and so on and so forth. Again, like I've said earlier, it's impossible to write down recurring decimals with all the digits inside. So we are just going to use the 3 dots at the back to indicate that this decimal continues forever. Now, a recurring decimal can also look like this, 0.94 with just a dot above the 4. So what does this mean? Now, if you realize, the dot is only above the 4. But for the 9, there's no dot above. So the 9 will stay. It's not going to repeat at all. But after the 9, you see a 4 with a dot above, right? So this means that the 4 will continue repeating, which means that this becomes 0.9444 and so on and so forth. So the 3 dots here indicates the 4 that keeps repeating. Next, let us take a look at the question. This question that I've given you has 3 parts. So let's take a look at part A over here. What do we have? We have 0.7 with a dot, and the question is asking us to convert this recurring decimal into a fraction. So first of all, let's write down 1 unit equals to 0.7 with a dot above. Now this notation over here is not very useful at the moment. So what I need you guys to do is to write this down in expanded form. Okay, pause the video for a while, write this down in expanded form. We should get 0.777 with 3 dots at the back. Now, what's the next step? The next step, we need to look for another decimal where the portion over here, that means the portion after the decimal place, looks similar. Now, how are we going to do that? Okay, if you realize, if 1 unit over here is just 0.777, if I take 1 unit and multiply by 10, okay, if I take 1 unit and multiply by 10, I should get 7.777 with the 3 dots at the back. If you observe carefully, the portion after the decimal place are now exactly the same. Over here, we have 0.777, and in 10 units, we also have the 0.777 at the back. Now, since these 2 portions after the decimal place are exactly the same, if we're going to subtract the 1 unit from the 10 units, it should give us a nice whole number. Okay, let's try and do that. So if I take 10 units minus 1 unit, that should give me 7.777 with the 3 dots. Take away 0.777 with the 3 dots. So again, if you realize, the portion after the decimal place is exactly the same, so they will cancel out each other. Now this should give us 9 units equals to 7. And from here, it is very simple because I can easily find 1 unit. 1 unit is simply 7 over 9. So since you've already said over here earlier that 1 unit is 0.7 with a dot, which is the recurring decimal, this is exactly the same as this 1 unit over here, which is 7 over 9. So therefore, we can conclude that 0.7 with a dot is just 7 over 9. Now let us continue with part B, which is another recurring decimal. This time around, there are 3 digits that repeat. Okay, do you see the 204 over there? The 204, not every single digit has a dot. There's only a dot above the 2 and above the 4. Okay, what does this mean? This means that when you write this decimal down in expanded form, you will get 0.204, followed by another 204, followed by another 204, and so on and so forth. So what are we going to do? For the very first step, we're going to let 1 unit equals to this recurring decimal, which is 0.204 with the dots above the 2, which is the first digit that repeats, and another dot above the 4, which is the last digit that repeats. Now, from part A, we know that we have to look for another decimal where it also ends with the 204. 204, 204. Now, how are we going to do that? So if you observe carefully, in order to get this next set of 204 and 204, I sort of have to make the 204 over here appear in front. Now, how do I do that? That is only possible if I multiply 1 unit by 1,000. So what is 1,000 units? 1,000 units is simply 204.204, 204, 204, and so on and so forth. So now if you realize, the portion after the decimal place look exactly the same. Okay, look at those 2 purple portions over there. They are identical. So now our job becomes very easy, because if you take 1,000 units, take away 1 unit, it is the same as this decimal over here minus the first decimal. So let's find out what is that. So I have 1,000 units minus 1 unit. That will be 204.204 ... Take away 0.204 ... So because the portions after the decimal place are totally equal, I'm just left with 204 on the right hand side. And on my left, 1,000 minus 1 will give me 999. Okay, don't forget to write down the units. And finally, I can find out what is 1 unit, which is 204 upon 999. Now be very careful. In such cases, always make sure that you simplify the fraction. So if you're not sure, you can always use your calculator, and you should get 68 upon 333 as your final answer. And also don't forget, because they ask us to convert the recurring decimal into a fraction, if you just leave your answer like that, 1 unit is 68 upon 333, it doesn't make sense. So you need to write down one more step, which is to say that 0.204, the recurring decimal, is the same as 68 upon 333. Okay, and if you don't believe me at this moment, everybody take out your calculator and key in this fraction. It should give you 0.204, 204, 204, and so on and so forth. Let's take a look at part C now. We have another recurring decimal, which is 0.53 with a dot just above the 3. Alright, if you notice carefully, there is no dot above the 5 at all. So if you're going to write this down, 0.53 with a dot above the 3, it looks like this, 0.5. And I'm just going to write down the 5 once because there is no dot above the 5. After that, because there is a dot above the 3, I can write down as many 3s as I want. Okay, I'm just kidding. You can go ahead and write down as many 3s as you want, but it will take forever, right? And you remember, recurring decimals are repeating until all the way to infinity. So there's no point in doing that. You just write down the 3 dots at the back. Now, many of you look at this decimal and will tell me, I know what to do right now. And what most people do is they will split up the decimal over here, this recurring decimal, into 2 portions, which is the non-repeating part, which is basically the 0.5, plus the repeating part, which is the 0.03 with a dot above. Now, this is totally fine. It simply means that your 1 unit is not the entire recurring decimal. So instead, your 1 unit right now will be your 0.03 with a dot above the 3. So let's do that. 1 unit is 0.03 with a dot. And if you expand this, you get 0.03333 dot dot dot, which means that the 3 keeps repeating. Now, when dealing with recurring decimals, I want to be able to find another decimal where the portion after the decimal place looks almost similar. So instead of 1 unit, what do you think we should look out for? Do you think 10 units will work? Okay, let's try 10 units. Now, 10 units basically means that you're going to multiply this decimal over here by 10. So the decimal point is going to shift. It's going to look like 0.33333. Okay, I've purposely written down 5 digits after the decimal place so that we can compare easily with the first decimal over here. Now, if you look carefully, the first digits, they are different. One has a 0, the other one has a 3. But the rest of the digits are all 3s. So if we take this decimal, subtract this first decimal over here, we're going to end up with just a 0.3. No more repeating decimals. Great. So now let's do that. 10 units minus 1 unit will give me 0.3. Which basically means that 9 units is 0.3. Or in other words, if you try to find 1 unit, okay, you will get 0.3 over 9. My goodness, this is really not useful. So if you guys are weak in converting fractions, you can simply take out your calculator. Okay, your calculator will do the job for you. You should get 1 unit equals to 11 over 330. Now, don't be too happy. Some of you will declare and tell me, teacher, this is my answer. It's 11 upon 330. But don't forget, what you have found is actually only your 0.03 with a dot above the 3. Okay, it is not this decimal that we are looking for. So the final step would be to take 0.53, okay, copy down the decimal earlier and write down 0.5 plus my 11 over 330. Now press your calculator, you should get your answer in its simplest form, which is 8 over 15. And that is one way of doing this. Now, if you realize there are 2 parts to this, right? I have a slightly faster method, which I'm going to be showing you in a moment. So my slightly faster method just deals with 1 unit as the entire recurring decimal. So if you expand this decimal, it will look like this, 0.5. Again, because there's only a dot above the 3 and there's no dot above the 5, you only write down the 5 one time and write down the 3 a few times. Okay, after this, what are we going to do? I need to look for another decimal where the decimal portion, okay, after the decimal place looks quite similar, right? So again, start small, think of 10 units. So let's see, will 10 units work? Now 10 units basically means you're going to multiply this decimal by 10. So the decimal point is going to shift right, okay, 1 decimal place to the right. So we're going to end up with 5.3333. I've purposely written down 4 decimal places because my first digit over here also has 4 decimal places. Now, if you're going to compare these 2 decimals, you realize that the first digit is different. One has a 5, the other has a 3. But the other digits are exactly the same, which means that if I take these 10 units, take away my 1 unit, I should end up with a non-recurring decimal, isn't it? So let's do that. What is 10 units minus 1 unit? I should get 5.3 minus 0.5, which is basically 4.8 equals to 9 units. And we have to find 1 unit. So 1 unit is 4.8 upon 9, which if you press your calculator at this point, will immediately give you 8 over 15. And don't forget, your 1 unit over here is your recurring decimal, 0.53 with a dot above the 3. So we can now conclude 0.53 with a dot above the 3 is the same as 8 over 15. So I've shown you 2 different ways to convert such a recurring decimal into a fraction, and I hope you found this useful. Thank you for watching. I hope you have enjoyed this video. If you found this video useful, give us a thumbs up. If you would like to check out more videos by us, please click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you guys again next time. Bye!